The 20th sum. A simple cipher takes a number and codes it, coding and decoding, and using the function f of x is equal to, just a function, f of x is equal to 3x minus 4. Find the inverse of this function. Determine the inverse is also a function. Verify the symmetrical property about the line y is equal to x by drawing the lines. So first let us write the function f of x is equal to 3x minus 4. Whenever you have to find the inverse, put y is equal to 3x minus 4. Find x in terms of y. Whenever you have to find the inverse, write x in terms of y. It is actually y in terms of x, isn't it? So we have to write x in terms of y. So 3x minus 4 is equal to y. So 3x is equal to y plus 4. So x is equal to y plus 4 by 3. So this is the inverse function. So the inverse function is, we'll write like this, inverse is, this is the inverse of this function. The function f of x is 3x minus 4. The inverse of this function is, just replace y by x. So it will become x plus 4 by 3. So f of x is 3x minus 4. The inverse is x plus 4 by 3. Now that first part of the question is over. Find the inverse. We found the inverse. Is the inverse is also a function. Now the inverse, this is actually, if you put this as some y, this is x plus 4 by 3 is nothing but 1 by 3x plus 4 by 3. So this is a linear equation. So the f inverse x is a linear equation. So a linear equation is always a function. This is a linear equation. Y is mx plus c with the m. The slope is 1 by 3. So when you draw the graph, it represents what? A line. Is a line with the slope m is 1 by 3. Put x is 2. 2 plus 4, 6 by 3. Y is also equal to 2. Put x is minus 1. Y will be minus 1 plus 4 by 3, that is 1. So let us draw the graph. So 2 and 2. You can see that minus 1 and 1. So this is that graph. Y is equal to, this is x plus 4 by 3. This is that graph, x plus 4 by 3. Now, so when you draw, this is a function. How do you check whether this graph is a function? You draw a vertical line. So we are going to check using the vertical line test. So what is a vertical line test? So when you draw a vertical line, it will intersect the graph at exactly 1 point. Okay, it should intersect the graph at only 1 point, not more than 1 point. If it intersects the graph at more than 1 point, then it is not a function. Here you can see the vertical line. You can draw any number of vertical lines. See, we'll draw another vertical line. This is the graph. The graph, it is intersecting only at 1 point, isn't it? So the line represents a function. Therefore this f inverse x is x plus 4 by 3 is a function. Why it is a function? By the vertical line test point. The vertical line intersects the curve at only 1 point, exactly 1 point. So it is a function. So we have proved the second part of the question. They ask you to prove it is a function. Yes, we have proved it is a function because the vertical line test we did, and the vertical line says that graph is a function. So second part of the question is also over. Find the inverse of the function. Yes, done. Determine whether the inverse is a function. Yes. Now verify the symmetrical property about the line y is equal to x by drawing the lines. You have to check the symmetric property. So all the lines we have to draw. First we did this line. Now we have to draw the function f of x. The given function is 3x minus 4. 3x minus 4. The second f inverse x is x plus 4 by 3. This is f inverse, and then you have to draw the line y is equal to x. So let us draw this line. F of x is y 3x minus 4. Just put one table, just 2 points enough. Put x is equal to 0, you get minus 4. X is minus 1, minus 7 points enough. Now this graph also let us draw. What is this graph? X and y are equal. Put x is 1, y is 1. X is 2, y is 2. Now let us draw all these 3 graphs. Look at these 3 graphs. This is the graph f of x is equal to 3x minus 4. And this one is the inverse graph. F inverse of x is equal to x plus 4 by 3. This is that line y is equal to x. So we have drawn 3 lines here. We have drawn 3 lines here. You can see that this y is equal to x, the middle line. This is like a mirror. It acts like a mirror. These two functions, f of x and f inverse of x, are reflections on either side. So along this side y is equal to x, these are symmetric. So f of x and f inverse x are symmetric about the line y is equal to x, or we can say y is equal to x act as a mirror. F of x and f inverse of x are reflections. And when you keep a mirror here, you can see the image like this. The image of this line will be like this. So, and it is symmetric. See the area, symmetric about the line. The same thing here, and this side also you can see same thing. Here also just see this and this, same area, same thing, symmetric. See.